Hi, Dr. Beach. So I wanted to do my last species report as a video. I also wanted to just quickly say that you're one of my favorite teachers I've ever had at University of Tampa. You were always very helpful, very nice. Your teaching style, I feel like worked really well for the way that I learn, and I really appreciated that you were sympathetic to the seniors who are going through all of this coronavirus stuff, as everybody is also going through it. So, thank you. Okay, so I'm going to dive right into the rest of the species report now. So, there's actually a group of polycricoid dinoflagellates, and it consists of two genera. And those two genera are Polykrikos and Polykrikos. And these two genera have been studied and debated on their classification for many years. Some even separate them into two different families, with Polykrikos being in the Polykrikosaceae family, and the Polykrikos in the Gymnodicea family. But for the remainder of this report, I'm going to focus on the Polykrikos genera, and that genus. And that genus actually consists of 4 different species, and the 4 different species are Polykrikos schwartzes, Polykrikos kofandi, Polykrikos lebrae, and Polykrikos grassae. So the first 3 of those species are well studied and distinguishable from one another. Also, I'm probably butchering how I'm saying every single one of these words. The genus Polykrikos is heterotrophic, meaning that it grazes on toxic planktonic larvae. And all Polykrikos species are marine and planktonic, except for Polykrikos lebrae, which is marine benthic, and it dwells in sandy bottoms. The distribution of this genus is dependent on factors such as water depth, sea surface salinity, and specifically for Polykrikos kofandi, it is dependent on nutrients from upwelling. The cellular anatomy and morphology of this genus is pretty complex compared to other dinoflagellates, and in my opinion, pretty confusing. They do have many different structures that are found in different groups within this genus, and I'm going to read some off because there's a lot and they're confusing. So, for example, they can have elaborate extrasomes, sulci, cinguli, flagellar pairs, trichocysts, nematocysts, tanocysts, mucocysts, and plastids. So Polykrikos species are multinucleated pseudocolonies with an even number of zooids. And zooids, they have one cingulum, a pair of flagella, and fused together zooid sulci. This genus also is athecate, meaning that they lack armor and they are considered naked, and their vesicles under the plasma membrane are empty. Polykrikos species reproduce through sexual reproduction by the fusion of gametes. Their gametes in Polykrikos kofandi have 2 zooids and 1 nucleus, and the zygote has 4 zooids and 1 nucleus. So the zygote morphology is determined by complex rearrangements of furrows and flagella. One thing that I found very interesting and confusing and different about this genus is I found an article. So in lecture, we talked about how dinoflagellates have a zygotic meiosis life cycle, but I found an article stating that Polykrikos kofandi actually uses a diplohaplontic life cycle, meaning that they use sporic meiosis. I read over the article multiple times to make sure I was understanding it correctly. I believe I am understanding it correctly. So I think that's very interesting that this dinoflagellate uses a different type of life cycle than the majority of dinoflagellates. This species has an alternation of generations due to meiotic divisions of the primary zygote's nucleus preceding nuclear cyclosis, and this allows the zygote to re-enter the vegetative cycle.